how to analyze, how to interpret, how to write about scanning electron microscopy data in a research paper. This technique is very important in every top research paper. Every good research paper must include these techniques. So let's get started. But before starting, let me tell you very important thing. When you want to take SEM images, if you are taking by operator or you are taking by yourself. So for example, here we have two samples. One is the control sample here and one is this modified sample here. So for example, for this control sample, if you want to take 10 images, right? If you want to take 10 images for this control and 10 images for this modified surface. So all magnification must be same. For example, when you start from 2 micrometer, so this one will also start from 2 micrometer. When you see here, this is 1 micron here and this is also 1 micron here. Then you can compare two morphology. For example, if this one is 200 nanometer and this one is 1 micron, mean 100 nanometer. So how you can compare these two morphologies? So the reviewer will raise questions, the examiner will raise questions. So this thing is very important. Look here, this is the cross section here. Again, the authors took the same magnification. This is very important, and this is my duty to tell you that when you are taking SEM images by yourself or by the operator, tell them to take the same magnification for different samples. So let's get started. Before writing a discussion, you can write that what basically you want to know. For example, this is the pristine surface when there is no additional amount, when there is no modification. And this is basically a polymer HPDA. It can be different in your case. So when we add this HPDA with this surface, so we can see that there is a significant change in the morphology. And how do we will know that whether this solvent basically change the morphology or not? So because of, we know from SEM, because SEM is acting just like eyes for nanotechnology, eyes. Because of this SEM, we see what happening to the surface, what happening to the morphology. So we can start like this, that SEM measurement was conducted or measurements, then we will see work conducted, etc. to characterize the influence of HPDA. Yes, we want to see whether this HPDA do some modification to the surface, doing some changes to the surface or not. So yes, to find the impacts, the changes of HPDA to the perovskite morphology, to the perovskite surface. Yes, so clearly there is a change. When there is a change, because I know these are basically grains here. As I mentioned many times that when we are talking about the SEM, so we have to talk about the grain. And when we are talking about the XRD, so we have to talk about the crystals, the crystallites. So yeah, we can see that the grains basically changes significantly. And we can see that the grain sizes increases here. So we can write about this. The grain size of the HPDA modified perovskite film is much larger than the control or the pure or the pristine film is shown in figure A and B here. These are two figures. So this is very important to explain this discussions here. You can also talk about other things if you can see, but these are the major things you have to explain. In the next videos, I will also use some other images to explain different things in SEM images. Now here we can also see this. This is basically the surface morphology, and this is basically the cross section of these two similar film. What is cross section? This is basically, so we can see here, this is basically the surface morphology. That is basically the surface morphology. Just like I explained, this is perovskite here, this is the surface morphology. And now when we cut that, so this become cross section. This is the cross section now, you see. So for example, from the surface, I know that the grain size increases, but I don't know inside what is there inside the perovskite. So this is very important. So I have to cut this. When I cut this, so I will see the cross section, and let's again see whether there is the same trend in the cross section or not. So this is the cross sectional image here. This is the glass here. This is maybe the ETL or something, or simply glass, and this is basically the perovskite layer here. This is perovskite and this is perovskite, and we can see here that the control structure, the pristine structure, does not have clear grain, and there are a lot of grain boundaries here. We can see here, just like here we have large number of grain boundaries. When the grain size are smaller, so the grain boundaries will be more. For example, smaller the grain size, smaller the grain, smaller the grains, mean this is directly related. More grain boundaries, more grain boundaries. A large grain mean less grain boundaries. Yeah, this is very important. For example, if you have the same surface area, this is the same area. Let's suppose this is a centimeter square or millimeter square or whatever. So in this particular surface area, we have large grain. This means that there will be large grain boundaries. So when we want to occupy this with less grain, this means we have to increase the size. The increase the size, we decreases the grain boundaries. And grain boundaries are unwanted phenomena because the cracks occur there, and the humidity, the foreign moisture, water can enter to the device, etc. So less grain boundaries are fine here. Let's read this. So this is the control cross section here, and this is basically the modified cross section. So we can clearly see that very big grains are also appearing here. You see very big grain here. Yeah, this means that this structure modified a lot. So we can see that the cross-sectional image of HPDA modified perovskite film shows vertical oriented neat grain, very clean grains, while the pristine film shows irregular and small grains. You see irregular. The grains are oriented this way, here this way. You see here is this way. So this is how we have to write about this. So in smaller grains with numerous grain boundaries. This is very important discussion you have to include in your research paper. This data I took from this important paper. You see here, this is the SEM graphs I took from this important paper published in Nature Communication by Zihao Li et al. In 2025 under a common lessons CC 4.0. This is the link to the Creative Commons 4.0 international license.